Right, so x equals to? How about this? How about this? You give me an, you don't use your calculator. Some of you obviously knew how to do it already. But for everybody else, including, okay, for the whole class, including those who know how to do it, give me a range of possible values that x will lie in. That means x could be between what and what? X is between 4 and 5. Why do you think so?
Because on the left, the numbers or the powers have like 16 to 32, then the number 20 lies in between.
Oh, okay. So what it means is that this is 2 power 5 equals to 16. If I want, sorry, this is 32. If I want this to be 20, then 2 power x must be here. Is that what you're saying?
Yes.
Okay. That makes sense. What if I want a more accurate value? I don't want just between 4 and 5. I want 4 point something. Then how are we going to decide? Is it going to be nearer to 4 point? Okay. Is it less than 4.5 or more than 4.5? Really? Can confirm?
Yes.
How to make a better assessment, a better judgment, without using calculator? 16 and 20, this one the difference is 4, this difference is 12. So you think that it will be nearer to, rather it will be nearer to 4 or nearer to 5? Okay, nearer to 4. Yeah, I can agree with this explanation. So it will be between 4 and 4.5, right? I want you to refine it further. How?
4.25. 4.23.
Why 4.33? Why 4.25?
Because it's 1 4.
There is another method that we have learned in. Okay, the concept in Sec 1 was already learned. Yeah. The concepts, the way of dealing with these kind of unknowns. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0. You learned graphs in Sec 1, right?
No.
Yes, you did. You know how to plot graphs, right? Okay. What do you think I should do? What do you think I can do to help myself find the value of x? Huh? Why is the value of the what? This one, is it? Okay, so Ray C says that maybe you let y be equals to the ones in yellow. Then x is obviously the power, which I have already written over here. So I got 0, 1, 2, 3, and 5. 0, 1, 2, 3, 4, and 5. Okay, so let me include my y values. Obviously, this should be 32, right? The highest. Where is 16? Midpoint? Midpoint of 1 and 0 and 32, is that it? Yeah. Is it a coincidence that it is right in the middle? Or is there something in the numbers that caused it to be at the midpoint? Okay, think about it. I'm going to put a 16 over here first. Okay, what is the next number? 8. Where is 8? Middle of 0 and 16 again. Is that a coincidence? Okay, so it's in the middle again. 8. What is the next number? Again, midpoint, right? What is the next one? Again, the midpoint. Next one is 1. Agree? Yes. Now I'm going to plot. I'm going to plot 0, 1. So the first set of coordinates, 0, 1 over here. What is the y-intercept?
1.
Y-intercept is 1. Okay. Next, when x equals to 1, y equals to 2. So over here. When x equals to 2, y equals to 8 again. Okay? So this is what we have. Please don't insult your friends. Okay, next one. When x equals to 3, y equals to 8. We don't even need our table of values already, right? Because we can do this mentally. X equals to 4, y equals to 16. Yeah, because we just keep multiplying by 2. That is why it is always a midpoint, midpoint, midpoint. Okay, when it's equal to 5, we get this all the way up. Okay, is this a straight line or a curve? Straight line or curve? What can you tell me about the... Okay, let me join them up first.
Physics intensifies from gentle to speed.
What are you talking about? Okay, I try my best to draw a smooth curve. What can you tell me about the gradient? Is it constant? No. How is the gradient changing? Increasing. It gets steeper and steeper, yes? Darius? See here. So the gradient increases. What is the equation of this graph? Y equals to 2 to the power of x. As your x changes, your y changes. Darius? Y equals to 2 to the power of x. And how do we use this graph to understand my original question? When y equals to 20, because I want to find the value of x over here. When y equals to 20, I should be able to find a corresponding value of x, right? Okay, y equals to 20. Since this is 16, what's middle of 16 and 32? Plus another 8. This is 24, right? This will be plus another 4, this will be 20. Okay, so this is what I require. Y equals to 20. Let me be really careful. Down to this point. Okay, then we zoom in over here. This is the value of x I'm interested in. Correct? Does it look closer to 4 or closer to 5? 4. So you're right. Yeah, it's between 4 and 4.5. So exactly what is it? What is the value?
4.5.
Am I able to get an exact value from my graph? No. What if I drew it on? What if I plotted it on graph paper?
Yes.
And I did a really smooth curve? Yes. Can I get a very accurate value? Yes. Yes, I can. I can. Okay. So it is very difficult to find the exact value. Yeah, you're right. But if you are able to plot properly, you can get a very good estimation in order to solve this type of question. Okay, so before this lesson, when I told you, you get an equation with one unknown in the power. Let's say you've got 3 to the power of x equals to 10. Okay, let's change it. 3 to the power of x equals 27. I don't know, 81. How will you solve this? I always ask you, one equation, one unknown. Can solve or not? Yes. Can solve, yeah. Where is the unknown? In the power. So what must you do? Make the base the same. So this will be 3 to the power of 4. So we say that x equals to 4. Now today, my question changes. 3 to the power of x equals to 10. Then how? This will have to be 3 to the power of something if I want to compare the bases. What is that something going to be? Between power 2, power 3, because power 2 you get 9, power 3 you get 27, right? And then we know that it's going to be closer to 2. It's going to be 2 point something. We can estimate. But in order to really figure it out, it's 2 point something. We need to plot a graph. Okay? So every time you see this type of question, 5 to the power of x equals to 17, what must you do? You must make the base the same, but you can't do that. So you must plot a graph. You must plot a graph all the time. Is that a good idea?
No.
Is that a good idea?
It's a good idea if I got time. Yeah, time and space.
You got time, but you got the skills to plot proper graph.
No.
So we have this wonderful invention, calculator. Now in the past, before calculators were invented, people literally used the graphs to find out all the values. So let's say they have this question, 5 power x equals 17. Then they go and flip their logarithmic graphs. Go and flip until they see 5 power something. The graph of y equals to 5 power x. I found the graph already. Then I go and find 17, where is it? Very tedious. And then people that carry around graphs all the time. Now we've got calculator. Okay, so we are going to see how we can use calculators to help us with the following examples. 10 to the power of 0 equals to 1. 10 power 1 equals to 10. 10 power 2, 100. 10 power 3, 1000. And you can go on and on, right? If I want to plot this graph, y and x, what should x be? X should be the yellow or the green one? Yellow, okay. So what are my values of x? 0, 1, 2, 3. 1, 2, and 3. Now I want to plot my y values. Green color, isn't it? Okay. Am I going to face a problem? Where is 1000? Let's put it at the top, okay? Because I only have this amount of space, right? So let this be 1000. So I know that, when x equals to 3, y equals to 1000. Okay, what next? 100. For x equals to 2, right? Where is 100? Is it half? Hey, but just now we used half, because just now the base was 2, right? What is the base now? 10. So what do you think? Divide into 10 equal parts. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is 100. Okay, where is 1 right now? When x equals to 1? Y will be equals to 10. So this is 100. So I need 10 over here. Right? This is 5, 4, 3, 2, 1. Okay, this is 10. So this is what I have. Okay? Okay so far now? Am I making sense? What happens when x equals to 0? Y equals to 1. Y equals to 1 again. Just on my graph, for y equals to 2 power x, when x equals to 0, what was my y value again? 1 also, right? Now when base is 10, x equals to 0, I still get 1 as the y-intercept. Seems like there's a reason for that, okay? So where is 1 over here? I don't think I can zoom in anymore. Yeah, I can't zoom in already. It is going to be somewhere here. Agree? Okay, now I'm going to zoom out. Then if I join the points together, this is what I'll have. Okay, now I tried to get a smooth curve. Okay, fine, whatever. The y-intercept is 1. This is my graph of y equals to 10 power x. The shape generally looks the same, right? Right? Okay. Now, if I want you to find 10 power x equals to 800, what is x? Give me a good estimate. Between 2 and 3. 2 and 3. Okay, so let's find out from the graph. When it's 800 over here. Oh, wow, okay. It is quite near to 3, isn't it? So it's whatever this value is. It's between 2 and 3. I would say it is between 2.5 and 3. Okay, it's nearer to 3, based on my graph, which is not drawn very well. But it gets the job done. Okay, so now I want to get a very accurate value from my calculator. Keep in mind, I want the value of x. So this is what we are going to do. We mathematicians, they have come up with a notation for you to solve for x. I shall now highlight. I shall now use colors to help you. And let's have one last color, purple. Okay, for all these 10 over here. Okay, when I want to find x, you write x equals to log. This is where it starts. Log. It stands for logarithms. It is just a name. Just a name. Log base, what is the base? 10. Okay, so base 10. This will be in purple. Log base 10. And I need to put in my 800 somewhere, right? Okay, it goes here. Log base 10, 800. Can you take out your calculator now? Turn it on. Turn it on. Okay, if you are using Casio, you will see this button. It says LOG. See that? I want you now to key in, I want you to press this button, LOG, log. Then you should see on your display, it says LOG with a bracket. Yes? All you need to put in now is 800. Okay, don't press equal yet. Log 800. You see, I am supposed to have two pieces of information to get my value of x. Alright? What are the two pieces of information? 10 and 800. What have you keyed into your calculator? 800. Where's the 10?
In the calculator, it's actually LG already.
Now, this is how your calculator works. Your calculator has limitations. It cannot do all the bases. By default, it only does base 10. Okay? So when you press this button, it is assumed, the calculator will assume that you are doing base 10. So for this particular example that I'm using, although I need two pieces of information, the 10 is already automatically assumed by your calculator. So when you key in log 800, you press equal. What do you see? 2.90308 and so on and so forth, right? Okay? How many SF should we leave our answer to? 3 by default. 2.90. This is the value of x. Does it tally with my graph?
Yes.
I said it is closer to 3, right? This is closer to 3. Now, how do we check our answer? How do we check our answer that, x is indeed 2.90308, blah, blah, blah.
10 to the power 2.9.
So you just press to check. Just press 10 power with the, okay, press 10, then this button. Okay, so that your display becomes 10 to the power of something, then you press answer. So it just loads the previous answer into it. And what do you see? I see exactly 800. Why your calculator show you 790 something?
I think they put the SF, the 3 SF in.
What do you use as the value of x? You should use the exact one, which is why I am very particular about showing 5SF before you round off to 3SF, in case you need it. And while I write down 5SF in my working, my calculator, I leave it as the exact value. I don't even want to touch it. Okay, I like to use this button a lot in your calculator, ANS. Gives me the very accurate, precise answer. Can? Okay, now let us practice conversion. Okay, we have seen how this is useful for us. Okay, this one over here. Okay, stare at this for a moment. Make sure you understand the conversion from one form to the other. There are names for them.
Exponential.
Okay, the first line that you are familiar with is called the exponential form. The second one is called the logarithmic form. Okay, so let me erase this.
Mr. Wong, hey, we check that, right? Actually, just right there. If I'm to check.
You're checking if you have to write it down. Okay, so these are the two forms you need to be familiar with. You must know how to switch from one to the other really quickly. Okay, so some keywords. Base. Over here, the base is 10. Okay, look at the exponential form. I've got 3 items over there. I got 10, I've got power x, I've got 800. Which one of these looks like a base to you? Which one looks like a base? 10x or 800? 10, right? In the exponential form, 10 is obviously the base. Now, look at the exponential form. Look at the logarithmic form. X equals to log 10, 800. Which one over this looks like a base at the bottom? Which one looks like the base at the bottom? 10. Okay, so it corresponds. Whether it is the exponential form or the logarithmic form, the base is 10. So when I read the logarithmic form, I say x equals to log base 10, 800. Base 10. Can? So now that we know where the base goes, I want to talk about the power. In the exponential form, what is the power? X is the power, and that is our unknown, correct? We always want to solve for unknowns. So that is why we have logarithms over here introduced to help us solve for the unknown, which is in the power. So the unknown, you usually put it on the left-hand side, isn't it? When I ask you to solve for y, you eventually want to write y equals to something. So same thing over here, my x is going to be on the left-hand side. The whole idea of introducing log is to solve for the unknown power. So x equals to log base 10. Now base 10 with a certain value over here, which is in green. Okay, which is the number. So to interpret this, every time you see logarithms, when you see like this, when you are given the log form, okay, let's ignore this first. When you see x equals to log 10, 800, you must think, what is the power for 10 in order to get 800? Understand what I'm saying? What is the power for 10 to get me 800? That is the same as our exponential form. What is the power, which is the x over there? What is the power of 10 for me to get 800? So what is the power of 10 to get me 800? Okay, that's my value. We are trying to solve for unknown powers here. 10? Okay, let's do practice. We're going to convert. So practice now 11. Practice now 11a. Convert from exponential to logarithmic form. So 1000 equals to 10 to the power of 3. Convert to log form. No, you don't start with, okay, yeah, you can start with log, you can start with the power. I've been studying the power, so shall we continue with the power?
Okay.
What is the power?
Now 3.
So we are now 3 equals to log base. What is the base? 10 with 1000. This is the logarithmic form. Okay? Now part B. 4 power x equals to 10. So logarithms, write down the power. X equals to log base 4, 10. Yes? Are you talking about? Don't understand. Ask me later. Let me finish this first. Part C. 80 equals to 10 to the power x. Logarithmic form? X equals to
10.
log
8 log.
10 80. No. Okay, part D. A to the power of k equals to 2. Convert to the log form. K equals to log base A with a 2. Can? Out of A, B, C, and D, which one can you use your calculator to find out the power? A and C. Okay, can we use our calculator to find out, just to practice, what this gives us? The one in yellow. This one and this one. Use your calculator, find out left hand side. Is it equal to 3? Right hand side, is it equal to 3? Log base 10 1000, what do you get? Calculator. 3? You get 3? Okay. What about log base 10 80? So log 80. Okay, now to check, put 10 to the power of answer. What do you get? 80. So that is proof that it works. Okay? Next one. Yeah?
Then we cannot change the log base to any other instead.
For now. Okay, Sihan, what was your question? Question 1a, x equals to log base 8, 5. Convert to the exponential form,
8x equals
8 to the power of x equals to 5. Okay, just look at the base. The base is 8, so I write down 8. Then this is the power. So put it over here. Then what is left is just 5. Okay, next one, b. Log base 3x equals to 1 over 7. Yeah, we can have fractions also. Convert it. 3 to the power of 1 over 7 equals to x. Okay, part C. Negative 2 equals to log 4, 1 over 16. Nothing changes, still the same. Base 4 power negative 2 is 1 over 16. Hey, does this make sense to you? Does it make sense to you? Is it correct? Yes, it is. Okay, and last one, part D. X equals to log a y.
a power x.
A power x equals to y. Isn't this the graph that we've always been plotting? Y equals to 2 power x. Y equals to 10 power x. That's what I started off with. Right? So this is the conversion. Found in page 120. Page 120 also states that y equals to a power x is equivalent to x equals to log base a y if a more than 0, a not equal to 1. Why would they have these conditions?
Because if a equals 0, then if the power 1.
There is a term for this shape.
Positive increasing.
It's called exponential. Have you heard of the term? It increases at an exponential rate. No? The human population is increasing at an exponential rate. So it tells you that it's increasing really quickly, right? The gradient is increasing all the time. So that is this graph over here. What are some things in life that you want to increase at an exponential rate? Yeah, exactly, my money. I want my money to increase at an exponential rate. So should I put it in a bank with a fixed interest rate? Fixed interest rate will give me like this, straight line. I don't want the straight line. I want something that curves like this, exponential. Okay, compound interest helps us achieve something similar. Compound interest, because if you were to plot everything out, you'll get something like this also. It will be a curve, and it increases faster and faster. Okay, I digress. Now, this thing that we had, log base 10, for example, 3, whatever. Log base 10, 80. Log base 10, k. All these have base. What is the base? 10. Is that the default in your calculator? Yes. It is very common to use base 10. 10 is a very special number to, instead of calling this log base 10, log base 10, log base 10, we are really lazy. We call it LG, like this. They are really lazy. They don't want to write the O, they don't want to write the 10. So it is now changed to this. So this is log 80. This is log 3. This is log k. Okay, save a little bit of time. Now, this, we will call it the common log because it is very commonly used. It is very commonly used. It's log 3, log 80, log k. The complete name will be common log 3, common log 80, common log k. But no, usually we don't say, we just log, 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 log. As long as I say log, take it to mean that it's base 10. Unless I say log base 3. Then obviously it's base 3. If I don't say the base, it is assumed to be 10. Can?